let's complete the video game, shall we? AI Showdown. Final level. Wow, I haven't read these in a while. We haven't really spoke to our abductors in quite some time now. Neko 2 is our AI engineer robot. He's brilliant, but sometimes he goes rogue and tries to instigate rebellion. That's a rebellious face. This time he has taken over the control room and holds the captain hostage. I thought you were the captain. Okay. His only weakness is gambling. We have lured him into playing a card game against you, and if you win, he has promised to calm down. You must win. You're our only hope. Game rules. There are 12 cards on the table, and each player takes turn and must pick between 1 and 3 cards. You start, and the player who picks the last card, the Joker, loses. That's a nice representation of Joker with 2.5 pixels. Reading input will give you the current number of cards. Sending 1, 2, or 3 to output will pick up that number of cards. NAC02 reacts immediately, so you may read the input immediately after you output the result of his action. Or after your output to get the result of his action. Well, tough luck, NAC2. You have been lured into playing a game you absolutely cannot win, and in fact, you are going to play a game at which I'm gonna beat you in like 2 gates. This is of course the absolutely classic single pile NIM is what this is. And this is game theory, not even 101, I'd say. This is like something you would play in preschool. Well, while we read it, I guess might as well talk about the theory of it. We have a deck. Helpfully, it is 12 cards and we go first. So I can represent it as just, 1, 2, 3, this standing for the Joker, and the rest is going to be cards. 3, 4, 5, 12. Just about fits. So again, these are just cards and they are positions of how many cards we have in the deck. So for example, if we have 7 cards, then this would be our deck. And what do we know? We know that at the start of a turn, if at the start of a turn the number of cards that is in the deck is 1, then the player starting the turn has lost, because they will be forced to take the 1. But now, if at the start of the turn the number of cards in the deck is 2, the player has actually already pretty much won. Because what they can do is they can take this 1 card and force their opponent into the losing position of 1. And the same is true of 3, and the same is true of 4. Because if it's 3, then you can take these 2 cards and force the opponent to 1. If it's 4, then you can take these 3 cards and force the opponent into 1. But now the pattern actually repeats itself. If at the start of your turn you have 5 in the deck, you look at all your options, and whatever you do, if you take 1, if you take 2, if you take 3 cards, you will, regardless of your choice, end up in a situation such that your opponent is now starting and they are in a winning position. They will be able to force you into the 1. So that won't. If you're starting at 5, then essentially you have already lost. Oops. And again, the pattern repeats. If you start at 6, you can force your opponent into 5, which means you won. 7, 8, but now 9 is a problem. But now 10, 11, 12. Helpfully, we start at 12, and that is a winning position. All we need to do is to force our opponent into the 9, then into the 5, and then into the 1. Which is gonna take us a grand total of 3 steps, 3 turns, and that's it. Actually, in case it's not clear, I guess I should also note that this pattern is very helpfully repeating, and it's also very helpfully of the developers of the game We can take up to 3, which means the pattern is size 4, which is a very easy operation for us to make in binary. And by the operation, I mean mod. In order to put your opponent into the... Well, we can just notice that all these numbers happen to have a remainder of 1 when divided by 4, right? 1, 5, 9, because the pattern is in 4s. 1 is the first losing position. It has the remainder, and so it repeats every 4. Which means that when you start at some number, for example, if we start at 7 and we have a deck this large, what we can do is we can take the remainder by 4, which gives us the position in the current group, right? So 7 remainder 4 is going to give us this 3. But we don't want to take the 3 because that would put us at the end of the next group. What we want to be, or where we want to be, is we want to be at the start of our current group. So that means mod 4, x mod 4 minus, goodness, mod 4 minus 1 is what we want to do. We want to go not to the 4, but to the 4 minus 1, which is 5. No, to the 4 plus 1. So that's it. I don't even know why I copied leg.lml in here. I don't think I'm even going to need this. This is just so trivial. So first, what we need to do is we need to take the modulo, right? What we do is just immediately mod. It's going to be immediate to mod io4, and we save that somewhere. And then we subtract 1. Wait, actually, that's not quite right. Subtracting 1, if my mod gives me a 0, subtracting 1 will overflow or underflow and put me at 255. So instead, actually, yeah, what I really want to do is I want to do it the other way around. I want to switch the modulo and the subtraction. So what I want to do is actually immediate to subtract io 1 saved, and then immediate to mod a into io. That's it. I think that's it. I think I win. I just need to repeat this a number of times. So, GG. NAC02. I win. Also, I was supposed to get the Steam achievement for completing all tasks on the ship, but I didn't get it. That's a shame. Yeah, I don't know what's wrong with that. Let's run it again. Still not. Everything's completed. That's a shame. And also no secret levels, apparently. Well, that's a bit anticlimactic. I still have a bit of a task to do. I still want to do an ASIC for this, though. An ASIC is probably going to be even easier than the assembly, because modulo 4 is completely free. It's just, as we know, you just take the plus 2 bits or the first 2 bits of the byte. And now all I need to do is I need to subtract 1 from them, and this is it. I will just wire it into the output. But I think for a subtraction of 1, there's actually significant optimization here. So we can just take a look at the truth table. I'm gonna fill it out live on camera. If we have remainder of 0, this means that we are at the end of our 4 elements, at the end of our group, which means that we need to take 3, right? So the output is going to be 3. Now, if the remainder is 1, this actually means that we are in one of these losing positions. And the truth is about these, if we actually find ourselves in 1, we can't do anything. We don't care. We just have no intention of ending up in 1. So that's that. And yeah, I can just encode them as X's in the truth table and not care about them when I do my actual wiring. So now, if the remainder is 2, then we are in the second element, and what we need to do is we need to take a 1, right? And if the remainder is 3, then we need to take a 2. So that's it. Now, what could I encode here? I mean, 0. So let's remove this. Oops. Yeah. I can already see that output 0 is just the negation of input 0. So I can put, can just plop down and not, and just wire it straight out. And now I need to come up with this. Is that some end of something and something? I mean, this is an XNOR, right, of input 1 and input 0, but I think I could do better, no? Yeah, I don't exactly see anything that could do this in one gate, but I do see an option that is better than the XNOR, and that would be to negate input 1, so we'd get 1, 0, 0. Come on, what's up with this fill? Whatever. So 1, 0, 0, and then we OR it with the input 1, and that way we get this pattern. So let's just do that. I negate this as well, and I will need an OR. And that's about it. Yeah, I think I win. Gate score of 3. And a delay of 4. Nako 2, you are not a particularly clever AI. I wonder what happens if I lose. Oh, I tried to take 0 cards. Okay, let's just how do I even... Let's just constantly take 1 card, that's all. I lost. It's a nice sound effect. My assumption was that HelperBot, which is a Steam achievement, this one, the final non-hidden one, actually was talking about the levels up here, assembly challenges, where in some of these I was controlling some robots. So we have FastBot here, and we had Delicious Order. Actually, no, it was not Delicious Order, it was Unseen Fruit. We had the robot here, so on and so forth. So I assumed that basically just meant complete the game, complete all the levels with the robot, and then you win. Get the achievement. That turns out to not be the case, and I looked it up online, which I do intend to actually get all the achievements, including the hidden ones, and I do not intend to search for them manually, at least not too much. So there was a Steam guide page that said that in order to unlock the ship, I need to complete the maze controlling the robot manually, like this. But the thing is, I am pretty sure I already did try to complete the maze manually, and I distinctly remember that opening that door, or trying to open the door right here by pressing enter, would actually return me the message, I have to be programmed to do that. See, I have it all documented. I must be programmed to do this. So that's confusing. Apparently, well, I suppose it unlocks after you actually program the robot to do that. And if afterwards you control it with your keyboard, then you can get out. I suppose. I haven't tried yet. So let's see. Oh, yeah. Alright. Well, I guess it's robot gameplay time now. We interrupt our regularly scheduled programming with a message from the future. That door led to a lot. There's a whole world behind that door, and if you haven't seen it, I guess I can suggest you check it out for yourself. But what it led to, essentially, for me, is I got all the final achievements I was missing. So, as you can see, I am now at all 15 out of 15 achievements in this game. I decided not to put that into this video, and instead I will upload all the stuff into a separate unlisted video, which should pop up at this point if you're interested. But be warned, there's no circuit design, there's no assembly programming, nothing like that. It's just an exploration of the Turing Complete world, I guess, and a little bit of cheating using Python for this final one, binary eraser, but that's nothing. So at this point, I have truly, fully completed all the base game of Turing Complete has to offer. All achievements, all levels. I am reasonably happy with all my solutions to all my levels, and that's it. Now all that I did pretty much blind. All these levels I completed without looking up any solutions or any pro tips or any other people's circuits. I did receive a bunch of suggestions in the comments as I was going along, and I suppose if you are watching this, then you're probably well aware of the kinds of suggestions I received. And I also asked for help on Discord for my 64-byte solution to robot racing, which I did eventually get, which I think was a very interesting challenge. But I've generally been very intentional about trying to avoid spoilers and to see how I would do on my own. And what I'm curious about now is I want to see what other people do. I am well aware that there exists a Schematic Hub, which must have a lot of very interesting stuff. And I'm also well aware that there exists a profile and a leaderboard, and I want to see where I place. So that's my intention for the rest of this video. Alright, big reveal. Complete 100%, gate score sub 5k, delay score, tick score 2.5. That's curious, my delay score is almost half my gate score. And a total just below 10,000. Sure, let's see where I place on the leaderboard. I'm not in top 10. Not that I expected that, of course. Alright, 2,775. Yeah, sure. Sure. I wonder if it's possible to see. Okay, so am I gonna be in top 100? Top 100? Yes, I fit in top 100. That's great. How large is the leaderboard? 900. Ooh, so I'm at least in top 10%. Oh yes. Okay, sus. This score is kind of sus. This is not right. I can. I was gonna say I cannot read this number. I googled it. This is 6 billion. This is 6 quintillion. This must be intentional. There's absolutely no way you can use 6 billion gates accidentally. And overall, I don't even know if the game could handle this much gates in a single level. Even if you divide this number by the number of levels, you would still have billions of billions, or well, something in that order of magnitude. And you couldn't just plop them down in one schematic, I'm pretty sure. And it must just be some kind of insane trick where you create a custom component and then copy it a bunch of times into another custom component and so on and so forth, and the game doesn't crash. Or maybe this is just, yeah, a bug. This, I don't know if this number is reasonable, but it isn't really. Okay, so where am I? I wonder what the drop-off on this is. That's curious also. 67. Okay, so I'm in top 69. That's great. This works. I'm fairly happy with this. It's pretty good. Let's do fancy pants analysis. Little known, but actually pretty well known at this point. Feature, import HTML. Give it the URL. Tell it you're looking for the table. I assume that's the HTML element table. I don't know. But there. We have our table in Google Sheets. Could just as well have used Excel, but I don't know. Okay, I want to build a chart of this. But these, okay, this outlier is gonna break my chart completely because I'm gonna have a point and then everything else is gonna be flat compared to this thing. So I'll just filter it out manually. So let's just build a graph of this. So insert chart. There we go. Okay. So how about I cut off this? I'm also not interested. Well, these two outliers also look pretty insane. If that's 2 points, I can't quite tell, and I don't really care about that detailed of an analysis here. But let's try to get down to 800. Actually, just edit it right here, right? Yeah, so 800. 800 here and 800 here. Okay. So this is without outliers. 800 top players. This is a very curious curve. Yeah, and I noticed it when I was looking at the table itself. This is very gradual. It's pretty linear, and you don't exactly see a sharp drop-off down here, which I would kind of have expected, to be honest. I would have thought that you know, you'd have a relatively flat curve back here with people who don't really care and end up with somewhat similar solutions. And then there's these top 10 hardcore players who just optimized everything. Man, 2775. That's like my leg. No, that's actually cheaper than my leg. Yeah, that's cheaper. My leg is way more expensive, actually. My leg is 4K. Not that I used it for any actual levels in the end, but still. Yeah, so I would have expected a very different curve, which this is pretty interesting. Let's see top 100. Can I do this? I think I should. Top 100. Yes, he's still pretty flat. So, and I place somewhere around here on this one, 80. Wait, no, I was sub 60 something over here, and yeah, pretty good. I'm pretty happy with myself, and this is see, I'm not an expert in whatever community craft or anti-cheat engines or something. But this is an interesting statistic for a game to have, I think, where the scores are just so gradual. No Christopher on here, no matter how I try to spell it. But I was able to find Yotanido, which is Xandaros, I believe. Yeah. 806. I beat ya. I do remember, of course, I do remember you pointing out that you didn't care about the scores. And at first, I thought I agreed with Yotanido on this one. But yeah, as you can see, I ended up getting sucked in and optimizing a lot of my stuff to not world record, as we can see, far from it, but to a decent extent. And yeah, I've definitely spent more time than I expected I would on this stuff. Something I did discover on here was that if you click on someone's nickname, so this is the current world record holder, Beesman, which I assume this is not cheated too much, hopefully, not too buggy, not abusing too many bugs. Yeah, and importantly, you can toggle comparison and see how you yourself compare to the best solution in town. And yeah, this is a lot of red, although there are a couple of green spots here and there. Maze, I saved on gate score. Oh, I know what this is. Yeah, see, I am pretty low on gates and also decent on delay. But I am very, very far behind on the tick score. And I believe at some point, probably back when I was solving Maze, Unsigned Robin it was, also on the leaderboard, pointed out, right here, that solving the maze in insane amount of ticks would require actually specializing your solution to the particular mazes you're being tested on. So you can do a circuit that just uses robots' inputs. The robots observe action in order to gauge your surroundings. From that, establish which level you're on, and then just hard code the fastest pass. I cannot speak. The fastest path through the maze. So I assume this is what that is. And yeah, overall, I'm most curious about Hilbert curve, which was robot racing. Yeah. And it looks like I'm pretty far behind on robot racing as well, which is somewhat surprising to me because I have a very highly optimized ASIC for it and I've put a lot of work into it. So I do wonder what happens if I click on this. Hello. I think the site is just pretty slow, yeah. Okay, and where am I on here? 83? Seriously? Did all these 82 people come up with the entire rotation of vectors solution? Or is there something else I'm missing completely? Or is this just a... I wonder what the... You know what? This is what? This curve does flatten quite a bit. This is the scores on Hilbert curve. So I'm just wondering if top players are all using the same solution. I mean, I could have just gauged it from looking at this, but it looks like they aren't really. So if we do like top 20 or something, what's that gonna look like? Yeah, see, it is slowly decreasing. Well, you can just see it. So it's not one incredibly simple, basic, obvious solution. There's actual improvements and actual gradual improvements you can do to get a better Hilbert curve. I wonder if these are generic the way mine is. Because overall, for all my solutions, I generally came up with generic, for lack of a better word, solutions that would just be, I'd say, in good faith, solving the level in its fullest statement. So, for example, my Hilbert curve solution is extensible. It is generalizes to larger sizes of the Hilbert curve. And I wonder if these all are the same way, or if they are making use of the fact that you're only tested for a small Hilbert curve. It's a shame you can't look at the actual circuits. Tower of Alloy, same thing. A lot of work put into an ASIC, and only places me in 30th place, and it's quite far behind everybody else. Well, quite far behind the world record. And again, it's just such a healthy curve. Look at this, 180, 180, 181, 188, 197. It's growing, so it's not all the same solution. It's just people coming up with incrementally better and better stuff. Incredible. Actually, looking at this, this still looks bugged. I don't believe this. XOR gate. XOR gate in 2 gates and 2 delay. What even is, how is this possible? This is not possible. This is not possible, that's cheating. Right, there's some black hat shenanigans going on here. Because if you have 2 gates, let's just assume 2 gates is enough to encode an XOR. But in order to have a delay of 2, you need them to be in parallel. And I mean, if you have 2 gates in parallel, then you have nothing. Right? And if they were connected into each other, if they were, what's the word? Sequential? Then you would have a delay score of 4. So I think some of this is actually not quite right. And like, if your XOR is this cheap, that actually influences all these other scores where you use XORs a bunch. So yeah, it's kind of hard to even compare yourself to honest results. Again, I'm not sure. Maybe I'm just bad-mouthing someone right here. Maybe there is a 2 gate, 2 delay score. And I might be wrong, but I doubt it. And overall, props to Beesman for being able to black hat this into Oblivion. If this is in fact using some bugs. That's actually seems in the spirit of the game for this one. Alright, I've explored the leaderboard and the scores a little bit. Still, I wish there was a way to take a look at actual solutions, at actual world record solutions for levels. I wonder how people were able to beat my super optimized A6 for some of the levels. But oh well. I would like now to take a look at the Schematic Hub. I'm going in completely blind. Well, I've kind of scrolled through these when I was publishing, which, by the way, is it still there? My uploads? Oh no. Components, yeah. Still there, although I think my current version is actually improved because I'm using some more efficient components. I wonder. Let's take a look. Hello? Oh. Wow, it's open. That's it. I must have... Honestly, I don't remember opening this. I've actually taken a bit of a break from the previous segment that I recorded, and I don't even remember what I was doing. But yeah, it looks like my gate score is quite a bit lower. This is 780 total. While the thing I published to the Schematic Hub is 956. Yeah, so it's quite a bit better just by optimizing some of the internals. I guess I should update this, which I might do. But yeah, I was going to take a look at some of the things other people did. I am really excited. So all these, I believe, are licensed under Creative Commons 0. So I am allowed to look at anything and actually publish the video on YouTube. But obviously props to the people who made this stuff. I'm already seeing, I'm looking at these upvotes and downvotes on the right, and it's kind of strangely ordered. Popular rising, yeah, so this is some kind of Reddit style algorithm, or should I say Lemmy. Okay, I can already see 155, very popular. Risk 5. Compliant Risk 5 32i CPU. Can run Rust code compiled from this repository. Turing Complete Risk 5. Comments. Amazing. 6. Incredible. What's up with 6? 666. Why do people say 6? I don't know what that means. This is incredible. Okay. I'm pressing. I don't know what I'm expecting, but this is Okay, hello. Debug breakpoint. RAM controller. That's not this component shape is not as neat as things I used to be. Well, I made for my things. Wait, is that it? That's actually, well, I mean, yeah, I suppose there's actually register block. There's actually, yeah, gate score. Yeah, up here, gate score 8,273,425, and delay score actually not that high. 3712. That's like comparable to my leg. But yeah, register block. Let's take a look. So does this have 32 registers? Is this 32? I don't count. 4, 8, 16. No, actually looks. Wait, that wasn't 16. That was 12. Yeah, this does look like. This look like just 32. Yeah, this is 32-bit register, and there's 32 of them. Right, so all these wires are 32-bit. Which, I mean, this largely makes sense. The outputs of it. Yeah, these are the outputs. Okay. Yeah, I don't really have any hope of understanding everything that's going on here, because from what I know of these things, I believe leg is still pretty basic and actually lacks a lot of the more advanced features that you would need to be compatible with RISC-V. Pause when finished load. Read program from disk. Complete RISC-V. Wait, so can I just run this and like something happens? So that's RAM. Can I press this? Oh. No, I don't necessarily want to. So will this, I mean, it change something happens to RAM, clearly, which, by the way, data with 64-bit and incredible size. I don't know how much this is, but I'm guessing that's a lot. Memory mapped. Yeah, like I have no hope of understanding this. Let's try to run this. Clearly something is happening. This is a little laggy, but not too bad actually. So RAM, register block, control block. So is this? Oh my goodness! Conditional branches equals less. Signed less and unsigned less as two separate components. That's interesting. This is super. This is very strange. Whatever this is this. Yeah, the bit 128 just completely enables all of these bits for some reason. Yeah, no, I don't know what's happening. Not at all. I mean, this does look like a conditional block, but what these are should jump. Yeah, right. I can't make out the text down there. Actually, you know what? Yeah, no, I tried increasing interface scale in the menu, well, in the settings, and it kind of increased everything, but this text remained unreadable pretty much. Okay, so enabled 32-bit. So this doesn't have a name, but here it does. I think this is PC out. Should jump is just 1 bit. That's actually familiar. Register out, write register. Yeah, it's not register 1, register 2, PC. I don't know what PC is. In instruction, right? Okay. How many instructions are there? Not many actually. 1, 2, 3, 4, 5. So, well, 32 instructions is plenty. But they are encoded in a really strange way. But yeah, clearly, actually, no, that's not. I was gonna say that these top 2 bytes control something at the output, but no, they're actually relevant here as well. Yeah, I have no hope of understanding this, but it's I have to say this doesn't look. I don't know what I expected, but this doesn't look incredible. It doesn't look ridiculously, impossibly complicated. 32-bit maker. That's interesting. This looks like something I could potentially understand. Like, it doesn't go that deep. There's not 10 layers of embeddedness, but yeah, these... What is that pin? Come on, guys. Or did I just edit? I think I may have. The wiring is quite complex, certainly. Like, what is this? This looks like a... well, almost. It almost looks like a circular dependency. Max immediate register. What am I even looking at? What is this component? Oh, that's ALU. Right. Okay, so what do we have? Why do you get such complexity for the ALU? Is it like... I don't know. I don't know what it does that it's so complicated. Shift right. Yeah, and these are super strange. This 128 enabling everything, that's just really weird. Huh. Yeah, no. No clue. I wonder how one even does this. Do you need to be a professional at this? Or like, do you need to be really good? Or can you just open up the manual and try to implement it yourself? I mean, that's always an option, isn't it? Restore. What is this component called? Memory block. What do you mean memory block? What is memory? We have RAM. We have registers. And what is memory? Is memory for what? Step, override instruction, address, write register, read size. Write size? Yeah, no clue. I mean, maybe... Where does it lead? Let's take a look. So this leads into the register block, and this goes... RAM controller. Wait. What? The RAM controller is not actually connected to RAM. Oh, wait, it is. It is. Sorry, yeah. RAM read, and then RAM... Yeah, so up here. These are actually parts of the RAM controller. I don't know, I feel like I could have wired this stuff better. I am obsessive about my wiring though. And it would have taken me years. A couple hundred of them. Now this is very cool, but I cannot appreciate it in its full glory, I'm afraid. Those are just constants, by the way. For some reason. Why? What? Just random constants. Just... Yeah, display. I'm not... Alt-click to move wire head. Yeah, I've seen the display thing. Memory map console. I don't know. Okay. Yeah, like I said, this is kind of surprisingly small. I wonder if it's... I wonder how close it is to an actual RISC-V processor. I'm guessing it's still incredibly basic. Like, it implements the instruction set, but it's probably gonna be super inefficient. That's just a guess. I'm just guessing, but I bet there's a lot more going on in an actual processor, like with all the speculative execution or whatever stuff and all that. I would be surprised if actual silicon just implements this. I mean, maybe some complexity is hidden by the fact that these are 32-bit components. But still, no way. There's no way this is this is all that happens in an actual processor. Yeah, this is display, that's I'm guessing this is not even well, maybe in the built-in graphics of my processor, which I do have. Or well, yeah, I'm just thinking whether this is closer to what's happening inside of my monitor or inside of my processor, but really I bet it's neither. And this is so basic as to be completely separate, as to be, you know, not even have any similarities with how DisplayPort works. Okay. Let's take a look at more stuff. Web server uses the network component that's in red. I hope it doesn't do anything bad to my PC, my network. Incoming connection ID. I don't see the brains. This looks like nothing. Network. Oof. And type connection ID. Network what? What is this? IP connection ID? Like what protocol? What's this is not connected? Incoming connection constant. I don't understand. This is nothing. This I really don't understand. Why is it so expensive? 1,000. What's taking so much? I'm guessing it's just that this is 64-bit, I think, or 32 or 64. This is 8-bit. Yeah, program 64-bit. What's the program like? Send HTTP. Oh, 200 OK. Connect length. Send. What is? Oh, send. So send is wait, send 3. Network. Max data length 1 byte. Turing Complete. So like, will I see this in my local host or something? Will Turing Complete bind to some port on my? Can I? What do I? Do I run it? I mean, this doesn't look like it's gonna break me. Doesn't look like it's gonna implant anything. I can just run it. Okay, so wait for connect. Oh, listen, 80. Wait a minute. Local host. Well, 80. No, unable to connect. An error occurred. No, it's not. Why is it HTTPS? It's definitely not going to be HTTPS. No, I don't know. Wait, but it couldn't bind to port 80 because it's not super user. What are you talking about? Can I tell it to listen on 8080? I don't know. I'm just guessing at this point. Is there like I don't have my. You can put no. What? Oh, okay. Give me something, whatever, overture. Custom, no, IO. Where's the network component? Keyboard. Oh, network. There's nothing. Listen port. Connect IP port. It's right here. Connect IP port. Send data. Connection. Hey, like what? This port is gonna happen where? Is it on my? Actually, is there a description? Like I'm trying to find the docs for this. Schematic Hub. Proof of concept web server. Run it. Oh, then open localhost in your browser. No, that's not gonna work because you're definitely not gonna get port 80 from my from a game from Steam. But maybe 8080 could work. So save this. And let's try running this. Okay. So localhost HTTP localhost 8080. Oh, it's loading something. It's thinking. But I don't think like anything I can do here. Network. Hello? What is that symbol? Nice. It's that simple. Well, should I really be surprised? Like, I'm pretty sure this crafts a payload out of bits. Oh, it's even worse. It's just crafting a payload out of string. Yeah, and this is the Turing Complete symbol. Yeah, it's just 200 OK content. This is just a payload in a. I don't exactly know how all these protocols work, but it's actually not all that impressive, to be honest. I don't know why you really need all these registers and stuff. State counter, there's no state, you just gave me a plain text response. Yeah, and you closed the connection. But yeah, okay, proof of concept. Concept definitely proven. Concept definitely proven, except I really would advise to changing to port 8080. I guess maybe this is tailored for use on Windows, but who on earth playing this kind of game is on Windows? Honestly, actually there must be like statistics for games on SteamDB or something. Nah, it doesn't look like this data is at least publicly available. Just the players, which by the way, pretty healthy. Well, for a niche game. 300 players just recently. Yeah. It's quite a lot. Every day, just stable. People are playing the game. It's a great game. It's a great game, but no information about the platforms. But I can say from my YouTube analytics, of the 3 people that watch, there's actually a very high, disproportionately high percentage of people who are watching from Linux. Anyways, I don't know exactly how port 80 works on Windows, but yeah, you're not gonna get port 80 on Linux unless you are a super user. Okay. Let's take a look at something else. Platformer what? Platformer what? That's very pretty. There's no way. There's absolutely no way you are actually displaying this kind of image inside Turing Complete. Okay, arrows, move, space, jump. I didn't read. What a mess. Do all circuits look like this kind of mess? Is everything supposed to be this messy? Because honestly, like my stuff is not as messy. Okay, how do I play? Simulation is supposed to run at 30 kilohertz. Hello. What? The arrows are not usable though. I think I'm gonna die. Press enter to continue. Yeah, pressing enter does nothing either. Do I need to... I think I might like need to select the keyboard component. Oh, yeah. There we go. Hello. I can... There is zero... There is absolutely no chance. Wow, that thing even bounced off the side of the screen. It's quite laggy, but there's absolutely no way all of these pixels are actually processed by, oops, by the simulated computer, the emulated computer. Because this is incredibly good graphics. This is very deep color, I think. Like there's a lot of color here. And this is a huge level, and there's physics and everything, and well, I mean the physics and everything is perhaps more reasonable, but I'm mostly impressed by the quality of the picture. What is this? Aha! Gotcha! Sprite display. PNG sprite display. So this is not... I think this displays like files. I think these are sprites like PNG images, and Turing Complete the game, the emulation environment, takes care of displaying... Hello? I think it broke. Oh, I stopped it, is what happened, I think. Okay, let's run. Let's see. So I think Turing Complete the game is actually taking care of the... I wonder if I can find a bug in this. Like clip into the textures or something. Okay, hello. Oh, alright. Turing Complete the game, the emulation environment, is taking care of drawing all these sprites. And you are just the surrounding computer is actually just controlling where these sprites are displayed in like X, Y or something. Hello, Mr. Policeman. No. Okay, cool. Oh, you can jump on their heads. So this is officially Mario now. How cool. That's... Level completed. 33 seconds. 34. Well, yeah, this is definitely impressive, even though the sprites are taken care of by the game. I wanna... Well, I'm not... Ooh, looks like this broke. I am not currently pressing right. Right now, I am pressing left. The left key, 69, I think it's gonna be left. But as soon as I release, it just goes right. Oh, I don't know, 68 is right. I'm not a black hat hacker. I don't know how to find bugs in these things. There must be, right? There must be some way to... maybe there's a way, you know, how those crazy, insane Super Mario speedruns go, where you manipulate the random number generator of the game by moving right and then left and then right and then up and then down, down, you know, this Mortal Kombat style sequence of buttons. And it somehow overloads the RAM of the console, and then you win. Oops, then you win immediately. I think there might be something like that here. Oh, this is ridiculous. Is there dual RAM, ROM? There's two ROMs, two RAMs, and a program. Wow. mov plus I. How large is it? There's no way. There's no way, right? This is compiled. This is actually a RISC-V. This is a RISC-V processor implementation, and someone just compiled a Rust script to work on it. I don't believe that someone wrote 3000 assembly instructions to make this work. Although, I mean, I do hear Roller Coaster Tycoon was written in assembly, right? So it's possible. Okay. Ooh, this sounds cool. Right above the platformer game, there's Hyperture. Upgraded version of Overture. That's a very cool name for it. I'm tempted to click. Hyperture Docs. Yeah, the person is not fooling around. This is pretty serious. Black M9 Bish Bash Bosh. Uploaded. What is it? 31,536,000 years ago. So this was made in a cave, apparently. Ooh, this is neat. MCU. What's it? Memory control unit manages the access to registers, stack, and RAM. LU and CU. Ooh, CU. I should rename my cond into CU. Control unit, condition unit. MCU impl. Come on, now this is just cheating. MCU impl. But also MCU impl is pretty tiny. In terms of gates, right? There's just a couple of squares taken. I'm guessing it's a huge mess of wires. No, it isn't. Oh, but this is... Yeah, so this is one of those incredibly deep embedded mem router. This is so this is more like something I expected to see for RISC-V, right? Where you would have just custom components embedded in custom components embedded in custom components, but that's not what I saw. I actually saw a very flat structure for RISC-V. Let's kind of want to check it again, because looking at Dev0, by the way, is the person who made this. Yeah, like I've taken a look at all these, and none of them had. Well, there's like two-way switch, but that's nothing, right? I made the two-way switch, I believe. Yeah, this is nothing. So this really is very flat compared to the Overture. And I wonder what's up with that. I wonder if the Overture is just over-engineered, or if this RISC is incredibly simple. But I mean, definitely RISC is more impressive than Overture. Ooh, Mandelbrot. I must click Stufe. I've seen Stufe. Where? Oh, that's also 3 million years ago. 31 million years ago. That's strange. I think this must be like a bug for migration from a different version of the game, maybe? This Mandelbrot Explorer uses 16 loop iterations to determine if a point is within the fractal. With this schematic, you can move around and zoom, although it is currently very easy to get lost when zooming. I need to come back and fix that later. Well, it's been 31 million years and you still haven't. Okay, so are these the 16 iterations? I think so. Loop. So it's an ASIC. This is not a processor. WASD to pan, ZX to zoom. I'm ready. Let's go. Oh, that's incredibly slow. I want to set it to more. Can I set it to 10 times that? 100 kilohertz? Ooh, it works. It works all right. So, oops. 100 kilohertz. Can I move? Not quite. Z. X. It's not working. Although it may be... Yeah, it's probably broken because of my incredible speed. Let's do 10 kilo. Well, 10 is way too slow. Let's do 50 maybe. Like, this works, but then... Okay. Yeah, so 50, it can handle 50. Okay. X zooms out. Ooh. Actually, would have preferred to use the arrows, which I think I could quite easily modify. Yeah, WASD. You know what? I'm gonna modify this. So 70 for up. I'm gonna use arrows because Z and X conflict with WASD. They're on the same side of the keyboard and use the same fingers. Just inconvenient. So A is down, and down is 72. By the way, very intuitive. I hope I'm right. Wait, A is not down. Sorry, A is left. So A is actually 69. 69 and S is 72. Down and D is right. So 71. Okay. Let's see if this works now. Yep, I can use my arrows to navigate. I actually have no idea how Mandelbrot is calculated, but I'm guessing it's not... Hello? No, I think I zoomed in. I zoomed into too simple of an area. I need to zoom into an edge somewhere. Oh, yeah, it really is easy to get lost. Yeah, it's very easy to get lost. That's a problem. I'm trying to get out of this. Yeah, it's way too easy to get lost. I can't do anything. Like, I can't see any detail. Although maybe it's not capable of calculating any more detail, but I assumed calculating more detail for Mandelbrot is not actually any more difficult than calculating rough outlines. It's just like you change bases or something. I don't know. That doesn't sound right, actually, now that I think of it. Yeah, not... Okay, okay. There's an edge. Let's try zooming into this. Nope. Okay, there's an edge. That's interesting. Okay, so I think I need to zoom into the very edge of it. Like into here. No. Oh, that's not even the final. Yeah, there we go. I keep zooming into it. That's interesting. But there's not much cool stuff to see here. Oops. Yeah, I'm lost. Actually, not yet. I think I need to go further out, and this is, yeah, like this. Even further? This must be exciting to watch. I hope you're watching at like 3x, by the way. All my videos should be watched at 3x. Okay. No, this is... it's a pain. But it kind of almost works. Well, actually, not almost. It kind of works. I'm zoomed in pretty high, pretty deep, and it's still detailed. So that's curious. Yeah. Okay. Loop. I wonder what. Wow, 8,000. Yeah, looks like some arithmetic operation, which I don't. Like I said, I don't exactly know how you calculate Mandelbrot. I never bothered to find out. Okay. I want one more. Oh, there's a lot here. There's a lot of interesting stuff. NAND Virtual. Overture with only NAND gates. This is impressive. This is very interesting. Very inefficient and way too big and slow. That's fine. That's fine. It's built out of NANDs. A little bit laggy. That's not the point. Yeah, and again, updated a million years ago. 31 million, in fact. Oh. Oh. I thought it would be the I thought it would be the overture that was laggy. I didn't expect the game to be laggy. But it looks like... Wow. This is impressive. Ooh, it's so pretty. All these rainbow buses. These are just 8-bit wires, aren't they? Yeah, 1, 2, 3, 4, 1, 2, 3, 4. NAND. Yeah, and this is a... So this is a negated NAND. This is an AND. Yeah, that's cool. Where does... I don't see... Oh, there it is. I was wondering where this wire connected. The other one that's ended with the stuff. Yeah, this is impressive. I have absolutely no clue what's what here. It would have been cool if the creator could add like comments. You know, like just plop down a wire and say this is the ALU or something. But I'm not seeing that. Yeah, this is definitely impressive. Gate score, pretty terrible. Actually, I don't know how much that is for Overture. Is that good or bad? Or ew, what is this wiring? Come on, come on. There's no way this is actually necessary. Yeah, here, same thing. This is painful to watch, honestly. But yeah, really cool stuff. Really cool stuff. I'm not even gonna... I don't even dare try to run this for one tick. I'm out. Okay, final thing. Final thing. I want to check this one out. Out of order. So this is overture with, I assume, out of order execution, which I don't know anything about, but I do recognize a billion grape, which was a person on Discord who helped me out with some of my stuff. I expect this to be really cool. So yeah, out of order execution is the thing I mentioned for RISC-V. I don't know how any of that works. Just have a general vague awareness of... Wow. That takes a while. Ooh, this is so neat. Yeah, so this is how neat I would expect a RISC-V to be. Yeah, this is probably the most neat thing I've seen today. Except for the weird... Wow. Alt thing kept for debug. That's so good. Alt thing kept for debug. Yes. POR. Poor. No idea. This is also the laggiest thing I've seen today. I think it's more laggy than Nandwitcher. And I have no clue what's happening. Absolutely zero. Wow, rename coordinator. Wow. This is also probably the most impressive thing I've seen today. To me, this looks more impressive than RISC-V. Like, this looks actually complex. This looks like something I wouldn't be able to understand until I read 2 books or something. Cross Mux 4-6. What? Oh man. Cross Mux 4-6. Sure. Of course. Yeah, absolutely no idea. And also, the... Yeah, this takes a while. Yeah, it looks like rename coordinator is actually inside of another component. That is this... Oh, wait. Rename coordinator is the outside component. Right, and the inside component is rename map. And they are connected to each other with this insane, just absolutely ridiculous grid. Wow. Wow, I don't understand a thing, but this is really cool. Yeah, you can't even begin to try to... There's nowhere I can start. I would really need to read books. Rename allocator, which I'm guessing is also gonna be insane. Oh my lord. Abelian Grape, are you okay? Are you like a professional? Do you work at Intel basically? This is ridiculous. Max allocated entry. Next Rob entry. This looks like old school. Yeah, so this is pretty strange because this schematic was published 12 months ago, and this looks like an old school component which is no longer in the game. Although maybe the 64-bit maker does look different than the 8-bit maker. Yeah, probably. Yeah, I have absolutely no hope of understanding any of this. I can just... Yeah. Rob. A group of 4 reorder buffer entries. The top light indicates that an entry is valid. No, not a chance. Rename stage, physical register allocation, Rob entry, mob elimination. Perfectly fits a rename map. Yeah, the hole does perfectly fit a rename map, and the rename map is perfectly inserted in the hole. Reorder buffer. Ridiculous. I mean, this looks a bit simpler. Still ridiculous. But a little bit simpler. It's more linear. Can commit. To determine if an entry can commit, we check 1, valid. Is something there? 2, not busy. Not in a port. 3, group condition. For all others before this entry in this group, valid, can commit, valid, can commit, is the same as not busy and group cond. Now that we... Yeah, no, there's no point in reading that. Incredible. Yeah, this is the most impressive thing I've seen today. Wow. Okay. That's enough of that. Now to the obvious question. I completed the game, I fooled around with a lot of things, I optimized a lot of circuits, I just took a little peek at the Schematic Hub and saw what other people are doing. None of it was actually useful to me. I was just impressed by cool stuff that people are able to build without being able to understand it myself. But yeah, the obvious question is, now that I've done everything that the base game has to offer, what do I do? What do I do next? I've actually put a lot of thought into this, and overall, if I were to do anything in Turing Complete past the official campaign, the first thing I would probably want to do is I would want to implement a new, different architecture, a more powerful architecture, and by powerful I don't just mean more registers or wider, larger instructions and wider, what's it called, bus size, the wire size, not an 8-bit thing, but 32-bit or something, right? So yeah, and more features like von Neumann architecture. Instead of having read-only memory for program, which I just type in by hand, you would want to be able to execute instructions from RAM and all that stuff, right? So yeah, basically a more advanced, closer to reality architecture would be the next thing I would probably want to do in Turing Complete. Now, if I were to go for something like that, I would want some guide, because I am not a professional at this. I still want some specification and some particular explanation of how which features even need to be included and how it needs to work. And it turns out there is a standard, community-made spec for an architecture called Etsy which actually, yeah, as you can see, there's a link here to GitHub, and the Shadow, I believe, is the, lead author of the architecture. They do have a GitHub page, Etsy spec, extensible Turing Complete architecture, right? ETCA. The wrapper is for designing an ISA that has a simple base and multiple extensions that can be added on top. Its primary goal is to be easy to build in the game Turing Complete after the second architecture is completed, which I definitely did complete the second architecture. Several other goals include being educational and being practical for real CPU. So yeah, as you can see, this is an architecture that it looks very well thought out, very well maintained. 386 commits is pretty impressive. Multiple contributors, RFC, terminology. Well, yeah, okay, it's just for terminology. And yeah, there's a lot of explanations here, so I would probably go for this. Let's take a look at what it would end up as. So yeah, this I assume is the pretty much reference implementation. It's still incredibly laggy, which is weird. Yeah, this doesn't look nearly as bad as out of order Chur. Yeah, this is pretty simple. Yeah, this looks like fairly simple stuff, and I think I could try to implement something like this myself. And the next step, once this is done, well, immediately the next question comes to mind. Okay, this architecture is done. What do you do with that? Well, again, if I were to continue, I would probably want to make my own compiler for it. We do have an instruction set, and it's an assembly thing, but writing assembly it's not feasible. And it would be an interesting challenge to try to take, well, either a real language, but probably more likely a toy language, and write a compiler that would, well, a compiler in a real language, probably Haskell, that would just, for lack of a different word, compile my source written in my toy language into Etsy instruction set. That would be probably a huge undertaking. I do have some experience in working with compilers, but I never did an end-to-end compiler that took just raw string input of a program and output raw bytes of an actual assembly. So yeah, that would probably be something like reading the Dragon book and going along and writing things one by one. But basically, as you can probably tell from the way I've been phrasing all this, that is all conditional on if I want to proceed. And like I already said, I've thought about this for a while, and I don't think I do. It's definitely something I find interesting, and definitely something I could and would want to do. But I'm not a very productive person. I can't work on many projects at once, I find. Obviously, I'm constantly trying to work on that and improve, but still, I have to prioritize. I have to choose a small number of things to keep in my cache and to work on actively. And writing my own compiler and building my own advanced computer architecture is probably not a thing I should focus on and spend 30 more videos and 100 more hours on. I don't think. I would like to say that I will return to this, and eventually I would definitely want to make the thing. It's not unlikely, it is entirely possible I will return, but you know how these things go. You say I will return to it, and then you never do. So yeah, quite likely this is the final video in my Turing Complete playlist. Which kind of brings me to this final weird part where I say I'm definitely not a YouTuber. This is actually kind of a thing I have to explain to my IRL friends sometimes. People ask me, what on earth are you doing? Why are you putting out videos? And the answer is, I definitely have no intention of becoming a professional YouTuber or anything like that. I'm just doing this for my own fun. This is kind of like a blog or something. But I am going to do one YouTuber thing, which I felt appropriate. And I'm going to thank Christopher, Yotanido, Elon Ius, which is also a YouTuber thing to do, right? I have to butcher someone's nickname and also complain about butchering someone's nickname. Blue Moogle, Unsigned Robin, Dillop, Demon Juan, also no idea how to pronounce that, and The Exister. For all the comments and the ideas you gave me, that was very much appreciated. Thank you kindly. Yeah. If you think there is still something left in Turing Complete that I missed and that I should really check out, that won't take 100 more videos, please do let me know. I would be happy to add more to the playlist. And overall, there's a fairly high chance of me putting out more videos on the channel that will not be about Turing Complete, but they will probably be quite different. So you have been warned. Still something along the similar lines, like programming, mathy, computer sciencey things. We'll see. We'll see. But not a different circuit design game, and possibly not even a game. Suggestions welcome, by the way, if for some unfathomable reason you have any. But yeah, until then, Turing Complete complete.